Okay, welcome to Mod 1, Lesson 9 problem set. Now remember, the purpose of the problem set is for you to try it yourself and then check your work. Now if you absolutely do not understand what is being asked to do, then you go ahead and watch the first one as an example, copy it in your book, and then try the second one before you watch it. Okay? Alright, let's get started. Now this first one says solve and then write the sum in standard form. Use place value chart if necessary. So basically we're solving it in unit form, then we're going to rewrite it in standard form. Okay, so let's start off. Now if you see up on top, we have 1/10 and 2/10. So they're already in unit form. As long as they're already in the same unit, we can just add the digits. So we have 1/10 plus 2/10 is going to equal 3/10. Now when we say 3/10, that means 3 in the tenths place. So this is important for us to know our place value chart. We know we have in the 0 in the ones place, and then the next spot is the tenths. So we have 3 in the tenths place. Now on B, it says 14/10 plus 9/10. So once again, this is just tenths. So we're going to add these together, and 14 plus 9 is going to give us 23/10. Now if we were to rewrite this, we know 23/10. We cannot have two digits in the same place value. So the 3 would stay in the tenths, and the 2 would move to the left to the next place value, which would be 2 ones, 3/10. When we write as a standard form, we know 2 is in the 1 place, and the 3 is in the tenths place. Now on C, we have 1/100th plus 2/100ths. So we know we have 3/100ths. So when we write it in standard form, we know we have 0 ones, we have 0 tens, and we have 3/100ths. Remember that you always say the digit in the place value. Okay, the last digit is always in the place value. On D, we have 27/100ths plus 5/100ths. So once again, we can just add the numbers, and 27 plus 5 is going to be 32/100ths. And I know that 2 is going in the hundredths place. And that means that the other digit has to go to the left one position, and the left position of the hundredths is the tenths. So it'll be 3/10, 2/100ths. Now when we write a standard form, I'm going to start at the ones place, and there's 0 ones. We have 3/10 and 2/100ths. And we'd read that as 32/100ths. On E, we have 1/1000th, and it says TH, so I know we're talking about decimal, and 2/1000ths, and we're adding them together. So that's going to give us 3/1000ths. Now we're writing in standard form, we're going to start at the ones place. We have 0 ones, we have 0 tenths, we have 0 hundredths, but we have 3/1000ths. On F, we have 35/1000ths, which is a decimal, and 8/1000ths, which is also decimal. We add these two together, we're going to get 43/1000ths. Now, we know the 3 is in the thousandths place. The 4 is going to have to go one place value to the left, and to the left of the thousandths place is the hundredths place. Now when we write 43/100ths, we have 0 ones, 0 tens, 4/100ths, 3/1000ths. Now we come a little different. Notice this time we have 6/10, 3/1000ths. We just can't add those together, so we have to change one into the other unit. Now I know, and I'm going to come up top up here where we have some room. Here I have 6/10. And I'm going to write it in decimal form. There's 6/10. If I wanted to read this to the thousandths, I would have put another 0 here in the hundredths place. That'd be 60/100ths. Or I put another 0 in there, and we have 600/1000ths. So now I know I have 600/1000ths. And we're adding it to 3/1000ths, so I'm going to have 600/3000ths. Now when I write it as a place value, I know I start in the 0 spot, the ones place, which I'm going to have 0. Now I know I have 3 in the thousandths place. So I'm going to look to the left, and I got the hundredths, and I can see I have a 0 in the hundredths, and in the tenths I would have 6. So that's 603 thousandths. My last one, I have 7 ones, 2 tenths, and I'm adding 4 tenths. So that means I'd have 7 ones, 6 tenths. But if I was, since I know the ones is right next to the tenths, if I read it as tenths, it would be 76 tenths. And we would write that as 7 ones, 6 tenths. Our last example on this page has 2 thousandths plus 9 ones, 5 thousandths. Well, I know I'm going to end up with 9 ones, 7 thousandths. Now, on my place value chart, I'm going to draw a quick place value chart here. And I know this is my thousandths position. This is my hundredths position. This is my tenths position. And this is my ones with my decimal point right here. So it said 9 ones, 7 thousandths. Well, I know that I have to put placeholders in there. So if I read this to the thousandths, I would read this whole number. It would be 9,000, 7 thousandths. So it would be 9,000, 7 thousandths. And I can see, since I put it in a place value chart, for decimal form it would be 9 and 7 thousandths. All right, now at this time, we're going to start going more to the standard algorithm, okay? And I'm going to write these as I go, and I'm just looking at these two numbers I'm going to be adding. This one's in hundredths, that's 3 tenths. But if I rewrote 3 tenths into hundredths, I'd have 30 hundredths plus 82 hundredths. Now it's very easy for me to line up because all my digits are the same length. And when I add these up, I end up with 2, 8 and 3 is 11. I carry my 1. I got to make sure I bring that decimal down, and then I bring my 1 whole down. So this would be equal to 1 whole, 12 thousandths. On B, I can see they're both in the hundredths place. So I could go ahead and stack these if that's the way I'd like to do it. And I can just add them. 8 and 3 is 11. I know I can't put 11, so I have to carry my 1. Put a 1 down and 1. So we end up with 1 and 11 thousandths. Our next one, we can see they're both in the tenths position. So we have 7 and 3 tenths, 2 and 8 tenths. Now I could say 73 tenths plus 28 tenths. So if I went 73 tenths plus 28 tenths, let's do this one this way just to show you. If I added in the standard algorithm, 8 and 3 is 11, so I have to carry 10 over to the ones place. 7 and 2, 1 is 10, so I have to carry another one over to the tens place. And I end with 10 and 1 tenths. Now let's add up. We know we're adding tenths to tenths, so we're going to end up with tenths. 8 and 3 is 11, we carry it. 7, 9, and 1 is 10, 101 tenths. If I read this as a uniform, I could read it as 101 tenths. So there's a lot of different strategies here I'm showing you. You got to find the one that works for you all the time. A good mathematician finds the strategy that's good for them. So now first thing I'm looking at again to see what place value they're to, and they're both to the hundredths. So I'm going to do this one with standard algorithm, lining up my place values. Now I'm going to add them up. 8 and 3 is 11. I carry my 10 to the next place value. I have my 1. Make sure I put my decimal point in the right place. 7 and 2 is 9 and 5. So I'd end up with 59 and 11 hundredths. All right, so our last couple that we're doing here, I can see I'm written to the thousandths place in both of them. So there's 62 and 573. You notice I'm writing it out, and I'm trying to space my numbers out so I don't get confused. Because if you try writing real small, you can overlap place values. Now I'm using my decimals to line them up, and I know it's 4 and 328 thousandths. Now as you can see, my thousandths position is lined up, my hundredths position, my tenths, my ones, they're all lined up in perfect order, so now I can just add them. 8 and 3 is 11, I'm going to carry my 1. 7 and 2 is 9, 1 is 10, and I'm going to carry my 1 to the next place value because that's 10 being carried. 5 and 3 is 8, and 1 is 9. Put my place value in the same place. 4 and 2 is 6, and 6. So we know our answer is 66 and 901 thousandths. Now, if I wanted to estimate here, just to make sure, if I look at 62 and 5/10, I know that's closer to 63. 6 and 4 and 3/10 is closer to 4, so 63 and 4 would give me 67, and you can see I'm very close to 67 wholes. So that's just an estimation, just to verify that I didn't do something really wrong. My last example here, I have 7 and 3/10, 1 and 197/10, so they're both in the same unit form. So I'm going 85 and 703. Next one is 12 and 197. All my place values are lined up. 7 and 3 is 10. I'm carrying my 1. 9 and 1 is 10. Carrying my 1. 7 and 2 is 9 by my place value. 5 and 2 is 7. And 8 and 1 is 9. Now, as you see here, all these zeros right here, I do not have to put those in my answer. So my answer would be 87 and 9/10. Now I'm going to round these numbers to a whole number, closest whole number. So I know that 85, this here, if I'm rounding to the nearest whole number, would be 85 or 86. And I know my midpoint would be 87.5. So this is 0.7, so I know this one would round to 86. 12 and 1 and 97 thousandths, there's 1/10. I know it's either 12 or 13. This is obviously closer to 12. So my estimation should be 98. I made a mistake somewhere. So let's go back and see. Let's re-look at my work. The 7 and 3 was 10, carried my 1. 9 and 1 is 10, carried my 1. 7 and 2 is 9. 5 and 2 is 7. 8 and 1, oh, looky there. 9. So I should have 97 and 9/10. Now let's look at our estimation again. 86 plus 12, 97. Wow, look at that. An estimation saved me from making a mistake. Okay, so now we come to a word problem. Now I would like you to go ahead and try this yourself first, and I try to use the read, draw, write strategies you've learned in previous ones. You know, read the problem, identify the important information, draw something that represents the problem, and then write out your answer, which in this case you can just fill in the chart that's in there. And if you don't have any idea how to do it, just wait a second and follow along. Okay, so the first thing I'm going to do is I'm going to read. And I'm reading it the first time just to get the gist. I'm not trying to identify important information, I'm just reading for gist. Van Cortlandt Park's walking trail is 1 200 kilometers longer than Marine Park's. Central Park's walking trail is 242,000 kilometers than Van Cort's. Fill in the missing information chart below. And I can see Central Park, I don't have information. Marine Park, I actually have 1 2,800 kilometers, so I have some information there. That's obviously a place to start. In Van Cortlandt Park, we don't know, and I got to solve for that one. All right, so now I'm going to highlight some important information I have down here. So I know Van Cortlandt Park is 1 200 longer than Marine's. Central Park's walking trail is longer than Van Cort's. So I'm going to come over here and I'm going to try to draw me a tape diagram. And I'm going to start with, since I have this Marine Park, so I'm going to try to draw a tape diagram. And I know this one here is Marine Park, and it's 1.28 kilometers. Now, if I read this, it says Van Courts Park is 1 2/10 longer than Marine. So if I take this, and I'm going to draw it out here like this, and here's the end, and I know this is Van Courtland, and I know this section right here is 1 2/8 kilometers, but they said it was 1.02 kilometers longer. So I can see that if I needed to solve for Van Cortlandt, I'd have to add these two values together. And I'd have 1.28 plus 1.02. And I can see they're both in the hundredths place. So I can go ahead and come over here, and I'm going to put 1 28 hundredths, 1 2 hundredths. When I add these together, 8 and 2 is 10, carry my 1, 2 and 1 is 3, and 2. So Central Parks has to be 2 3/10 kilometers. Remember, I didn't need to put that hundredths in there because it was a 0. Now let's see what about Van Cortlandt's. Okay, it says Central Park Trail is 0.242 longer than Van Cortlandt's. Oh, so I can see that I would have to add another section on here, and that would be 0.242 kilometers longer. So I need to add that on to Van Cortlandt's. I wrote Van Cortlandt's in the wrong place, so let's go ahead and do that and get Central Parks. All right, so now we know that Van Cortlandt's was 2 3/10, and the other one is 242 thousandths kilometers. Now, if you notice, my place values aren't the same, but I can turn the 2 3/10 into 2 300 thousandths, so I can add them together. When I add them together, 0 and 2 is 2, 4 and 7 is 11, carry 1, 2 and 3 is 5, 1 is 6, put my place value in the same spot, and 2. So this one will be 2 612 kilometers. All right, now B. If a tourist walked all 3 trails a day, how many kilometers would he or she have traveled? Okay, so let's see. I know that Central Park was 2 612 kilometers. I know that Marine was 1 28 hundredths. So I'm going to change that to thousandths just to get a total going so far. When I add these two together, I've got 2983. So that's my total distance so far, is 3 892 thousandths kilometers. But I still have Van Cortlandt to add in, which is 2 3/10. And I like making them the same unit form. So that's thousandths, this is thousandths. We add them together, we got 2, 9, 8 and 3 is 11, carry our 1, and be 5 and 6. So they would have walked, and I would write it, I'm going to write it up on top. The tourist would have walked 6 192 thousandths kilometers. All right. Once again, try this one. Read it, identify the important information, draw a picture that represents it to help you solve it, and then after you solve it, write it in a sentence. All right. Meyer has 6,400 gigabytes of space remaining on his iPod. He wants to download a pedometer app, which is 2,400 gigabytes. A photo app which is 403 thousandths gigabytes, and a math app that is 3/10 gigabyte. Which combination of apps can he download? Well, I know he has a total of 64 gigabytes. So looking at this, the photo app, well, 64 hundredths gigabyte space, Now, can he do the photo app? That's 403 gigabytes. But if you look at this, let's take 64 hundredths of a gigabyte, and let's add a 0 for thousandths. That means he actually has 640 thousandths of a gigabyte. So the photo app he can do, which is 403. Now, if I were to try to do the math app, that would be 3/10 of a gigabyte. When I add these, make them all the same unit and add it up, we cannot have the math app with the photo app. But now's the question, can I have the photo app with the pedometer? So let's do this again. I got the photo app, which is 403 thousandths. Now we have the pedometer app, which is 24 hundredths. And when we change that to thousandths, that'd be 240 thousandths gigabytes. We add this up, we have 64.3. Oh, we only have 640. So we either can buy the photo app by itself. Now, can I buy the other two together? Let's see. If I had a pedometer, I'm going to short pedometer app, that'd be 0.24. And then if we had the math app, we would have, where's the math app? There it is, 0.3, 0.3. So if we add these two up, I made it both into hundredths, so it'd be 45.0. So, gigabyte. So we can either, I'm going to write it up on top, Meyer can either buy the math and pedometer app or the photo app by itself. All right, so you can see one of the key factors we have when we're adding decimals is one, getting them both in the same form. Whether it's unit form or standard form, we want to be adding tenths to tenths, hundredths to hundredths, thousandths to thousandths. Go ahead and convert one of the units to the other and then add them up, okay? Just like a whole number. Making sure you align everything by place value, and you're using your decimal point to line them up. All right. And once you're done with this, go ahead and go to the exit ticket if you felt comfortable. See you later.